A sound source emitting signal at a frequency fs moves along an arc of a circle with the constant speed v, as shown in the figure. For example, a car or something like that, it's moving in a curvilinear path, a curved path, with a constant velocity vs by emitting a sound of frequency fs. So that is a constant frequency; it won't change. There's an observer x. O is not the observer actually, right? A stationary observer is located at the point O. O is the center of the arc. O is the center of the arc. Listen to me carefully, right? O is the center of arc. X is the observer. Huh? This is the observer, right? Observer, right? Now, as the source moves, source is moving from A to B, right? When the source moves from A to B, the variation of the frequency f, right? In this case, the apparent frequency is indicated by f, heard by the observer is best represented by, right? So the variation of frequency f heard by the observer is best represented by, right? How it you can get the graph. That means frequency is in frequency heard by the observer is in the y-axis, and this is when it's moved along A to B. Observer is here, right? This is a different case actually, right? To easily identify the graph, right, what we have to do is we have to just find the component of this velocity, right? That means the horizontal component of v will be like this, no? When the source is at A, the horizontal component of v will be like this. Vertical component of the velocity will be like this, right? Now look at this. This observer is at x. This vertical velocity is perpendicular to the plane. This is the axis, no? Right? Axis where the observer is located, or observer is reside, right? So this velocity is perpendicular to the axis. That means the plane of the observer, right? So this won't affect the apparent frequency, right? Only thing, velocity that you have to consider is the vertical component. Vertical component, right? If you look on the vertical component, when the sound source is at A, vertical velocity is away from observer. When the source is away from the observer, the frequency heard by the observer is, right, will be reduced, no? So when the source is at A, the frequency heard by the observer, right, will be small, because this vertical velocity is away from the observer, right? When the source is at B, you can again find the component velocity of this V. Horizontal component is V, V cos theta or something like that, and vertical component will be there, right? Vertical component, look at the vertical component. Vertical component is towards the observer. When the velocity, that means when the source is moving towards the observer, then velocity will be somewhat, the apparent frequency will be high. So the frequency should vary from lowest value to the highest value, right? So when the sound source is at A, x will heard a minimum frequency, where whereas the source is at B, the apparent frequency heard by the observer will be high, right? So the graph should move along this point and this point, right? So is there any graph like that? This is wrong. This is also wrong. This is reducing, wrong. This is unchanged, wrong. This is correct. So the possible graph is like that, right? And I will explain why the pattern is like this, right? Look at that. When the source is at the mid part of the arc, the tangential velocity will be horizontal. Horizontal velocity won't affect the frequency. So when the source is here, right, let us say at C, right, at C, the frequency heard by the observer is same, Fs. Frequency heard by the observer is the frequency emitted by the source, right? So that's the reason at the mid part the frequency is Fs. So the answer is the second one, right? Question number 7, a train travels along a straight track, right? Another train the same direction behind the first train, right? A train is there, right? The train is there. Let's say that this is train number 1. Another train is also there behind this train along the same track, right? And same speed, same track, same speed, same direction. Direction also same. The train blows a whistle of frequency F0. Which one? F0. The train blows a whistle of frequency F0 if the apparent frequency of the whistle heard by the stationary passenger sitting in the second train. That means first train is blowing a frequency F0. Then what is the apparent frequency heard by a stationary observer at the train 2, right? Passenger in the train 2 heard by apparent frequency heard by the passenger in the train 2, right? That we have to find. Heard by a stationary passenger sitting in the second train is F. Then the relation, right? You can immediately answer this because these two trains does not have any relative velocity. Trains 1, 2, right, do not have any relative velocity, right, which means, right, F0 will be F, because according to the definition of Doppler effect, when there is a relative motion only, frequency will change, frequency heard by the observer will change, right? So there is no relative velocity, because if you find the relative velocity of 2 with respect to 1, then this is v and the other v is like this, then v minus v is 0. Relative velocity, you have to change the direction, no? So the frequency F0 will be F. The option is the third one, right? Question number 8. A source of sound and a listener are approaching each other with a speed of 40 meters per second. A source is there, an observer is there, both are approaching with the same velocity towards each other, Vv, right? V is given like 40 meters per second minus 1. The apparent frequency of node produced by the source is 400. Source is producing an the apparent frequency of node produced by the source is 400, right? Source is emitting a frequency F that will be heard by this observer, then the apparent frequency is given like 400. Right, this should be the apparent frequency produced by the sources, right? Due to the relative motion, right, the apparent frequency heard by the observer is 400, right? In a different way they have given like that. Then its true frequency in hertz, its true frequency in the sense this one, natural frequency, right? That is the question. Velocity of sound in AR is given. We can say this as V0. Velocity of sound we always want to indicate towards the observer, right, as V. What is the formula? Fa, that means apparent frequency is relative velocity of the observer, right? V plus V0 over relative velocity with respect to the source, V minus V0 into natural frequency. V is the velocity of sound in air, that is given 360 meter second minus 1. So this is 360 plus E0 40 over 360 minus 40 into 400. Right, if you solve this, it's not 400 actually, right? The FA is only 400. You need to find the frequency emitted by the source. Now if you find F from this, that will be 320 hertz. 320 hertz in the sense, the fourth option. Right. Siren emitting sound of frequency 500 hertz. Right. The siren is here. It's emitting a sound of frequency 500 hertz. Right. It's going away from the static listener. Going away. Right. This is the static listener. With the speed is also given. This one is 50 meter second minus 1. The frequency of sound heard by the heard directly from the siren is the question. That means we have to find the apparent frequency. Velocity of sound in air is given 330. Always you need to integrate this towards the observer. So formula is relative velocity with respect to observer, that means V over relative velocity with respect to the source. Right here V minus Vs. It should be V plus Vs, isn't it? V plus Vs into natural frequency. Now if you substitute this 330 over 330 plus Vs is 50, right, into natural frequency is given 500. This is 500, right? Now if you solve this, the answer will be 434.2 hertz. Is there any answer like 434.2 hertz? Option number 1, right? Okay, a man is sitting in a moving train. A train is there, a man is sitting on a moving train. The train is, the engine is whistling with the frequency 600 hertz. Then the frequency heard by the person is actually on the train. That means there is no relative velocity with the person and the train, right? So the frequency heard by the person will be the same, right? Will be 600 hertz. It will be same. The apparent frequency heard by him, right? The apparent frequency will also same. Heard by him is the apparent frequency as heard by him is 600. This is the correct option, third one. Because there is no relative velocity, because the man is on the train, so no relative velocity.